All right. Hello, everybody. Hopefully, you can hear me all right. Thanks for joining. Oh, whoops. One. Got a little bit of a delay there. Sorry about that. I had some chat open. All right. Well, thanks for joining. If you're viewing this on LinkedIn or Twitch or YouTube or X, good to see you. Today, we're going to be going over just some office hours. We're going to be doing a live Q&A, and hopefully we can get some more Synadians beside myself to jump on board. But welcome to the NATS Community AMA number 2. Hopefully this stream is working well. If it is, be sure to jump in the chat and let me know how it's working out for you. If the stream is clear or if it's fuzzy, that would be really, really good to hear from you about that. Excellent. Well, thanks for joining us. Again, we're going to be doing these kinds of AMAs or Q&As every couple 2 to 3 weeks or so, and it's just a way for the NATS maintainers, folks from Synadia, like myself, to engage with the community. I know we have a big kind of Slack community that a lot of people are involved in answering questions and things like that. But if we wanted to get into more in-depth topics, do a little bit of drawing, as well as kind of check out some new things that are coming down the pipe, we also wanted to have this as a venue to be able to do that. So again, thanks for hopping in and asking any questions. Just know, if you do want to ask any questions, I have it hooked up to YouTube chat to be able to kind of bring the question up onto the screen. And so if you do want to ask questions, it would be good to just visit our YouTube channel, catch the live there, and then you could ask questions. I'll do my best to kind of monitor all of the other chats as well and see if there's any good questions to pull up. But that's just kind of a little bit of housekeeping. Yeah, thanks for jumping on board. Wayne, Pablo, Marcus, Kareem, thanks for all joining. Yordis, I'm glad that you could join us today. Feel free to drop any sort of question in the chat. If there is something that you'd like me to go over, whether it's through code or whether it's through just being able to draw out a concept, I'm happy to answer any of those questions. And well, we also have a little bit of a backstage here where we can maybe have some folks who are interested in answering some questions from Synadia or can provide more context. They can also do that as well. Awesome. Yordis put 3 alarms in for it. That's great. That's good to hear. So yeah, we'll be doing a lot more of these in the future as well. But yeah, keep throwing some questions in there. Marcus says NATS takes away so many pains from microservices. Agreed. We just shipped a video yesterday on Jetstream KV, and the very next video that we'll be doing and focusing on is going to be much more around microservices. I know I have a microservices video when the whole micro library was fairly new. We have a lot more cool concepts to cover there, so I'm excited to be able to do that. Let's jump into kind of our lightweight agenda for the day. So for office hours number 2, just highlighting, we have a brand new video on this channel, this YouTube channel. And if you're watching from another, social media outlet, you can go to our YouTube channel, and we have a brand new, it's a 35-minute video that goes in depth on Jetstream KV. We do a little bit of everything there. We compare Jetstream KV to Redis a little bit. We dive into the internals and go over all of the commands and what they do and how they work. A little bit of how KV is driven under the hood and how it's just a stream. And then we also do some fun stuff like take a KV in Synadia Cloud and move it around the world. We mirror it and just kind of show how all of that automatic mirroring stuff works, which is cool. And then we also, I kind of showcase how to do a little leadership or a leader election system in KV. And so it's a little bit of everything, a little bit for everybody, which I think is pretty fun. So if you haven't gone and checked that out yet, highly encourage you do after this. But yeah, jump in, ask questions. This is what we're here for. We're just here to hang out. And I'm just going to kind of go over a couple more things. Yeah, I know somebody said that we don't have a shared calendar yet. That's something we're going to remedy pretty soon. We're in the process of rewriting some of our Synadia IO website, and I'd love to have kind of an event calendar in there that folks can subscribe to. I think that would be great. The next kind of order of business that I think would be fun to cover together would be this 2.11 preview. So Byron, Synadia's VP of Product and Engineering, just cut a new preview release, and he just notified me that there's a blog post due as well where he will go over some of the details. But I figured it would be fun to kind of go over. I know I've been alluding to some new features that are coming in 2.11, but it would be fun to kind of go over some of these and discuss some of them, and then, as you guys kind of participate in the chat, we can highlight any other chats or questions as we go through this and just answer anything. So, like I said, this is an open forum. It's here for us to kind of chat together, and yeah, it would be great. Sean, thanks for joining us. It's going to be good to chat with you more about stuff. Feel free to ask questions, any sort of question. Okay, cool. So let's go over this 2.11 release. I'm just going to read through it, and we'll go over each of these features. And I'd love to hear some feedback on what folks think about this. So this is the first preview release of 2.11. So 2.11 is our next kind of major-ish version of the NATS server. I hesitate to say major because according to Semver, it's not major, but we tend to use these kind of minor versions for NATS as our kind of like feature releases. And so that's where you're going to see new features come along. So it's not feature complete. We have a lot more planned for 2.11, and I highlighted some of these inside of the KV store video, that there's a lot of KV features that are coming, and some of these have been implemented, which is great. But alongside all of these, we will want to finish implementation on some of the other features, as well as kind of get client support for a lot of these, which I know is currently in progress. Pablo, again, thanks for joining us, and I hear your question around KV buckets and millions of keys. We'll talk a bit more about some things that you can do there and ways that you can optimize like large scale KV buckets. So this should only be used in development environments, not production, but we're going to continue to iterate on preview releases. And this is something new that we're trying, where we want to be able to make available like containers or container images for our preview releases, so folks can start kicking the tires with them, and we can get feedback a bit more early in the process. And so, we also just want to highlight that it's here. You should kind of kick the tires with it and start playing. And if you are kind of like interacting with a particular client, talk with your local client maintainer about what it looks like to maybe implement some of these features on the client side, because I know we have a lot of work to do there. So one of the big features, and I know Ari kind of drove a lot of the design around this, and we could even open up the ADR for this. But in 2.11, we have tracing coming, which is great. I briefly read through the ADR last week, and it all seems really good from a design perspective. We get a lot of information in terms of like driving spans and bringing in that OTel support, which I know it's something that people have wanted for a really long time. Here, let's go ahead and open up that ADR real quick. So yeah, let's look at this. NATS message path tracing. So as NATS networks become more complex with superclusters, leaf nodes, multiple accounts, and Jetstream knowing the path that messages take through the system, it's hard to predict. Further, when things go wrong, it's hard to know where messages can be lost, denied, or delayed. This describes a feature of NATS server 2.11 that allows messages to be traced through the NATS network. So NATS supports tracking latency of request-reply service interactions, and this is documented in ADR3. So if you guys haven't encountered this is kind of like, it's not a super well-known feature, but you can turn on latency tracking, specifically when you're doing like imports and exports. When you're exporting a particular service, you can do latency metrics tracking on that, meaning, we will emit like system events that you can subscribe to on a particular subject. You can emit events related to like both like the sampling and actual like request reply latency tracking metrics. And the cool part about this latency tracking is that it gives you not only like the RTT between like the actual full like request reply cycle from the request all the way over to the reply, but you get everything in between, like what was the RTT between the or what was the latency between the calling client and the NATS server, and the NATS server and the receiving client, and back. And so that was kind of like some precursor or some prior art to this stuff. But obviously that didn't take it far enough to be able to say, hey, what does it look like for us to really get some like OTel compatible, OTel compatible metrics for all of these things. And so this looks like a much more comprehensive implementation of this prior work, where it looks like we have multiple kind of tracing types or events that are being emitted. Your ingress, subject mapping, stream export, service import, jet stream and egress. So you can kind of know where in the life cycle this particular trace is taking place, because when you're interacting with a NAT server, there's actually a lot of different layers that it goes through. And so this might actually be an interesting ADR just to read through if you're still familiarizing yourself with some of the internals of the NAT server. But this is giving you like all of the details of kind of the layers that a message can go through before it reaches its destination. And so what it looks like is you can't necessarily I believe you can't necessarily activate it just full sail for an entire like NATS system or NATS server. In order to kind of trigger this tracing mechanism, you want to be able to, you're going to want to add a header to it. And so that way, you can tell NATS to trace this message. And I'm not going to go over all of this, by the way, but it's worth kind of looking into if you are using OTel open telemetry in some way, shape, or form, or you're doing like distributed traces, and you'd like that support inside of NATS. Know that it's very much coming. But we can even do stuff like trace across accounts. It looks like that NATS CLI has support for it with the NATS trace command, which is really, really cool. So lots of really fun stuff to play with. And I can't wait until this is released because I'd love to do a video on it. But what do you all think of kind of the OTel support inside of NATS Server 211? I'd love to kind of hear about it. And if you guys have any questions or want me to dive deeper into any of this, I'd be happy to do so, because there's a lot of really cool events here, here in the trace events. Something's going through ingress or subject mapping, a stream import or export between even between accounts, possibly. That's really, really cool. So yeah, it's so O-telling, Wayne. That's absolutely. Correlation and causation IDs, yours, I'm not sure. I'll have to read through this ADR more. I really just like glanced at it, and I haven't even been able to play with this yet, but I think this would be a fun thing to play with on a stream in the future. Cool. So that's kind of the first kind of bit for 211. We haven't even covered some of the other really nice goodies besides this one. So let's keep going. Support for batch direct get requests from streams. Give me 1 second. It looks like we can do a screen share of. It looks like somebody from Synadia wants to jump on. I'm not sure who this is because I don't know. This might be Ari. Let me see if I could pull him on and he can kind of showcase what the tracing looks like. Let me see if I could pull him in. Yeah, it is Ari. Cool. Ari, I'm going to add you to the scene, and let's see if this is going to work. I have your picture here, and I think your audio is going to show through at this point. Ari, I'm going to add you to the scene, and let's see if this is going to work. I have your picture here, and I think your audio is going to show through at this point. Ari, I'm going to add you to the scene. Ari, can you hear me? Maybe I can hear you. I hear something. Here's some music in the background. A little bit of echo. Okay. Well, if I can get Ari on board, that would be awesome, because it'd be great for him to do a little bit of a screen share there. But if not, totally cool. I'm going to leave this open for now, just for a minute or so, and we'll talk kind of about screen sharing is the challenge, he's saying. Yeah, I feel you. We're still figuring out how to do this stream thing and make it look good. So, okay, cool. Well, we will try doing screen sharing another time, because it looks like his video can't be shared either. Okay, we'll try this another time. Let me hop back in over here. Sorry about that. We will get a demo video of the distributed tracing really soon here. I think that would be a great one to have. And if we can get the screen sharing going, I'll kind of keep this chat open to see. All right. And then Wayne's coming in with more of the puns. Very great. Very great. Let's see. I'm going to go through and see if there's any questions that come up here. Clearstream on my end. Huge fan of NATS. Thanks, Kareem. Thanks for letting me know. Pablo, we talked about the KV buckets. Yeah, I want to get to that one because I think that is a good one to cover. And here we go. Yeah, so Didrik did ask this one inside of the NAT Slack not too long ago, and I wanted to kind of address this one. So, are there any plans or solutions to efficiently detecting services going away without overly chatting solutions? For instance, like service directory, leader election. Yeah, the use case details are in Slack. So this was asked in Slack, maybe like about like an hour ago. And this is an interesting thing to cover. So, and Didrik, you might have already come across this. I'm not sure, but one thing that I want to point out is that NATS has this concept of all of these system level events, and I believe we have a system event for account like client connect. I don't even remember what it is, and client disconnect that you can listen to. And we use this in Synadia Cloud to, detect when clients are connected or disconnected. Now, that's not necessarily going to map to your particular business domain logic because a service is, not necessarily always a one-to-one mapping to a particular client, but you can get pretty close with kind of being able to detect client disconnects and connects. And these will emit information about the client, like the subscriptions that they had at the time. That might be a bit outdated depending on how they choose to disconnect if they drain all their subscriptions beforehand. But you would be able to get some good information about these things. And you're right, and you kind of mentioned this in Slack that ConZ or our monitoring endpoints do kind of give you information about who's currently connected, but they could also give you information about who's been recently disconnected as well. Now, that's not a foolproof solution because the way a lot of our kind of like connection handling works is it's a ring buffer. So you're going to eventually those will get overwritten at some point, so you can't necessarily rely on that for full historical information. But we actually use it on Synadia Cloud when you go to cloud.synadia.com and if go log in real quick. It's going to have me log in with GitHub, so give me 1 minute. Just going to log in here. All right. And let's go over here and go over to connections, or actually users, CLI. There's no, oh, yep. You can see that my CLI did connect a day ago, which is cool. Node 1, 2, 3, 4 connected. They're actually still connected because I guess I'm still connected to them. Let's fire up this rethink connectivity. There's somewhere, oh, there we go. These guys are live right here. So I'm going to go ahead and disconnect them. And when I refresh this page, you can see that these nodes are now disconnected. And so all of this is kind of using ConZ on the back end to be able to query this. And you can kind of see how long they stayed up. But these are going to, because all of these things are stored in a ring buffer, these things are going to eventually just kind of fall off just naturally. So I know that doesn't fully answer your question, but I guess to kind of give you some pointers in the right direction, you have ConZ that you could look at, where you can also look at disconnected clients, but you can also kind of get those. You can get those more directly via the account client connect and disconnect. I know those aren't the right ones. One other thing that you could do is in the NATS CLI, if you don't already know, we have a NATS schema command. And I can say, let's just search. Here we go. So we have a NATS server advisory for client connect and disconnect. So the NATS schema command is a good place to kind of look for, the schemas for all these different events. I even think don't we have a NATS event? Yeah, NATS. That's going to actually show certain events inside of your cluster. But if you use schema, you can kind of get more information on this. So NATS schema info, and let's go grab that account connect and disconnect. So this is going to be a useful tool if you want to be able to kind of see how this thing works, get kind of the schema of it, and how to listen to it. So that's kind of a good way to go about it. We also have a lot of this stuff in documentation as well. Oh, I'm sorry. Yeah, the question is overlaying. I hear what you're saying. I'm picking up what you're putting down. Thanks. Let me see if I could get rid of that. And I was just running a NATS schema search connect, and that's where you're going to be able to get all this info right here. So there you go. Excellent. Let me see if I could jump in. Yeah, Didrik, as a follow-up, Didrik says, thanks for the answer. I was super excited about TTL auto events, and that made me think of this use case being somewhat close. Absolutely. Like that's another thing that you could do. And that might be kind of over the top because you already have a lot of these tools, available to you. But like one of the things that you could do is you could have a client essentially like send their own custom heartbeats via KV. And that's really what the leader election system is doing at its heart and soul, is like every 1 second, the leader is sending a heartbeat or a KV, update to that NATS KV being like, yes, I am the leader. Yes, I am the leader. And so in more advanced systems where, you start getting into domain logic, maybe you have, and this is where the per key TTLs can get really interesting. Imagine that you're building something like a scheduler, where you want to schedule and run container workloads. You want to build your own Kubernetes. And I'm not necessarily doing real architecture right now. I'm just spitballing, but this is something that you could imagine where maybe you have a deployment of sorts, and you want to say that particular deployment of a container, you want, 4 running instances of it. So you've basically just, told your scheduler that you want 4 running instances of it. And you could actually think of these in a way of like, these are just like slots in a KV, or maybe you put like a payload in them that says like these things are unclaimed or whatever. And then you have a bunch of processes that are kind of looking at this key space. Maybe that they have a watcher or something like that. And they can then notice particular slots that haven't been picked up, and that they go ahead and can run an update, or they can run a create in a different key space that maybe matches, a particular ID or whatever is generated to be able to essentially fill that slot. So then you have like, okay, this slot has been claimed, and then this slot has been claimed, and this slot has been claimed. And then they're sending heartbeats to essentially let the scheduler or the KV know that, hey, I'm still running this container. Its health is in this state or whatever. And now you have kind of a mini like Kubernetes or Nomad or things like that. So you could use KV, and especially with the TTLs and this concept of like sending heartbeats or updates at an interval as a way to kind of manage state in that interesting way. So that's why I'm really excited for KV and TTLs, and I think that's a really cool. You could build a lot of really cool distributed systems patterns with it. Okay, let's see if I could try to bring on Ari. He might have to mute me, which is fine, because what I can do is I could just give him the stage, and we'll work from there. So I might have to futz with my OBS, but let me see if I could try to bring Ari in one more time, and if I can hear from him. So let's see if I could do this. All right. Ari, I don't know if you can hear me. Let me see. Ari, can you hear me? Am I getting anything from here? Maybe. Maybe not. Oh, here we go. I'm seeing Ari's screen. Do you know what? I'm just sharing the wrong screen because I'm a dum-dum.
Ari, can you hear me? I can hear you.
I can hear you, yeah.
My screen is shared, so that
Your screen is shared. Let me give it some more. Space.
Here we go. I'm seeing Ari's screen. You know what? I'm just sharing the wrong screen. I'm a dum-dum.
Okay.
Okay. And can you hear my voice?
I'm gonna let you go, and I'm gonna stretch out your screen so you can demo it.
A little demo on the. Okay. All right, and I'll mute myself so you don't disturb it. So just a quick demo about the tracing. We are not implementing a full OTel publisher inside NATS. This can be activated through OTel, and you can receive the event, and you can turn those into traces and spans on your own. The basic idea is like, I'm going to send a message to this subject, weather.lime, and I'm going to connect to San Francisco. And you'll get a little bit like a trace route almost, right? I'm not sure if you can see that. Okay. You'll get a bit like a trace route, and what you're looking at basically is my connection is published into the subject. It comes from a client that connected to this cluster. It crosses an account boundary, which goes from my account to the weather account. It leaves San Francisco for New York for a gateway. In New York, it moves into a router, to another book, and finally that's offering the service. And so this is a little bit like a trace route, if you want. And this is interactive, so you just publishing it to a message, and here's one that's in the same account. There's no ground box boundaries. Here I'm sending a message to oops. Yes, that's great. And to another jet stream that is healthy. And it can show you that the full path takes even across leaf nodes. Here we move into a leaf node across node. And so it's about that primarily, but then you can configure it to receive OTel trace headers, and it will send you a bunch of things to a tool that you have to provide.
All right. Sorry about that, everybody. We ran into some more technical difficulties. I'm going to try to get a video up. It looks like our sharing is not working nearly as well as I hoped that it would. And apologize to Ari to have that get kicked out. We're going to try better to get this whole sharing and guest functionality. Maybe we'll just switch to Zoom for that, because this is definitely a bummer. I think we got right on the quality side, but it looks like yeah, we'll have to follow up with a demo. Yeah. Sorry about that, everybody. It is a really cool demo. I could see it on my end, but I'm hearing from folks that it kind of cut out. So sorry about that. We'll try again there. I'm going to jump in because I know that there are a bunch of questions that did pop up, and we'll try to get some more folks on next time with some better technology. Okay, so this question was asked by Zatho. This is more of an architecture question, but is it possible to use Synadia Cloud as the centralized source for accounts users for self-managed NATS supercluster? Yeah, that's a really interesting question. Let me think about this for a second. So what you can do is, oh, I see what you're saying. Yeah. So this is something that is going to be likely in a it will be supported in Synadia Cloud sooner rather than later. I don't have a date on it, but it's something that is scoped and is actively being worked on, I believe, by the team. But yes, we want to be able to have Synadia Cloud kind of act as like that, take more of that hybrid cloud approach where, you might have a self-hosted cluster, but you want to have Synadia Cloud manage all of your users and accounts and do the monitoring for you and everything like that. You can absolutely do that. We also, if your organization is using NATS and you want to be able to run essentially your own Synadia cloud, that's what Synadia platform is for, where you can run your own Synadia cloud in your own VPC. But we do want to offer that more hybrid option where it's like you want to run Synadia Cloud, or you want to just use Synadia Cloud, but point it to your own cluster. Yeah, that will be possible in the near future. Great question. Okay, let's see if I can pull in other ones. Wayne asks, with regards to micro and Next, are there any plans slash thoughts for defining microservices with Next configuration so that Next could run based on queued requests to scale up or scale to zero? Yeah, great question. Uh, I mean, this would be a great one to bring some folks on for, but obviously I'm running into some technical issues, so I wish I could. I wish I could bring somebody on. But yeah, I think the plan is to obviously very much support microservices within Next. I don't know if it's going to be something that's like directly supported, but it's something that we want to make sure that we're mindful of, that you can write, using the NATS micro library, and that Next will be able to support it fairly well. But I don't think it's necessarily like that Next will be the driver for that, more than like the client library would, and that Next may have some like awareness around it, quite possibly. And so that's something to think about. And for those who don't know what Next is is something that we're working on internally here at Synadia. It's open source, but it's a NATS execution engine, and it's a lightweight, I would say, I guess, runtime for being able to kind of like, ship. Right now it supports like ELF binaries, being able to kind of like ship binaries around and have them run wherever. And so the goal is to kind of have them run wherever like your NATS server is running, and using NATS is kind of like that, I guess, data plane, or control plane for that particular thing. So everything from being able to gather logs to being able to kind of like push that binary around in an object store to setting environment variables driven by KV, all that stuff is like based off of NATS. And so it's a pretty clean kind of alternative to like a more full-featured runtime like a Kubernetes or a Nomad. And so that's still in active development, but it's something that is super fun and feels super promising. I've been wanting to run workloads via via NATS for a long, long time. The other thing that Next supports is like kind of a serverless style, the functions as a service kind of thing. And so there's a lot to look forward to there, and hopefully we'll be able to demo some more of that stuff soon. Alexander asks, is there any news around the NATS operator? None that I know of. I mean, if there is somebody from Synadia in the chat that's asking or that knows more about the operator, let me know. Last I heard, there are some folks. I think you specifically mean the Kubernetes operator, like NAC. I don't have necessarily any news on it, but if we do, I'm sure somebody could jump in and talk about it. I know folks who have been using NAC, that there's some more features to be desired. I'm just not as sure where on the roadmap we want to be able to support that. Okay, let's see. Yeah, Didrik, as a follow-up to his previous question, that he experimented with system events, but mainly it was awkward with client IDs and mapping that to appropriate action to take, like tell everyone that the service URL is no longer active or so. Yeah, that's understandable. I think you would probably need some intermediary that kind of maps your business logic to kind of what's going on the NAT side, whether that's like a KV, or something similar. The cool thing about KV is, especially when we get those delete system events, is to remember that delete markers are a thing. So you can kind of historically go back and look at data that way. That might not work necessarily for TTLs, but if something is like explicitly deleted, you would be able to kind of get at that. Okay, we had a question about the micro framework. Wayne wanted to talk about kind of this architecture that I laid out right here. A Go app that schedules jobs is a reasonable architecture to change to use NATS, JS, KV, and work queues instead of a database for tracking job schedule definitions and execution tracking. What are the risks involved? Wow, that's a good question. I mean, I know a lot of people will typically use they'll even just use like a Postgres database to do some lightweight job stuff. But if you want to go more of like the traditional queue route, you absolutely can and use Jetstream for that. And I've seen people kind of use KV in tandem with it if they need to do some sort of locking mechanism or whatever alongside it. But like, yeah, I mean, I think NATS is just very well built for something like that. And I outlined it inside of my work queue video that was a few videos ago, but I go over kind of like, okay, how do you implement a dead letter queue? How do you implement kind of priority queuing and things like that? And the really neat part about all of it is kind of NATS will handle a lot of the geo distribution around it all. So if you need, if you have some locality to how you need to process things, you could split that up quite elegantly inside of NATS, where I think if you were to just use some centralized Postgres database, that would be a lot more difficult to manage. Scrolling down to more questions. Let's see. LW asks, what are the appropriate X509 usages to not have a server client topology and more of a peer-to-peer? Ideally, we want an infinitely extensible NATS cluster via leaf nodes. Yeah, that's also a great question. And when you're saying X509, like, are you talking about more mutual TLS or something different? I mean, one of the reasons kind of we designed the decentralized auth in the way that we did was to work with some of the limitations of X509 that we didn't feel like necessarily aligned to this kind of like pseudo trustless, I don't want to say trustless, with some zero trust constructs. And we still have a ways to go. I know personally, like Derek and some other folks are really thinking hard about what it looks like to make our auth scheme a bit more zero trust, specifically when it comes to like encryption and making sure we're not sharing like any data. Right now we share some metadata, right? But for like more of a peer-to-peer kind of thing, you could you don't necessarily have to lean on X509 for that. You could absolutely or MTLS per se, but you could lean on a lot of our kind of authn and authz that we have with the N keys for handling just that authn and authz. And if you need kind of the encryption at in transit, you can just use regular X509 for kind of peer to peer. I'd have to think about that. I don't have anything off the top of my head that'd be like, oh, this is the way to do it, or this is the way that you'd want to handle it. And I don't have any like architectures off the top of my head that have kind of used this like peering inside of via X509. Yeah, that's definitely an interesting one. But I have seen some people do like peering. I know the person who's working on Marmot was kind of like working on some peering like prototypes with that, and I'm not sure how he necessarily handled the certs for that. But yeah, people are doing some peer-to-peer stuff with NAT servers, which I think is kind of interesting, but it's not necessarily like a use case that we've designed explicitly for. But as far as the authn and authz side goes, we did consider some of that. Okay, let's see more questions that are coming up. Peter Morris asks, when starting a NAT server in Docker, is there a way to set the WebSockets value from the command line or environment variables? Ooh, good question. I don't know. I know it's absolutely available via the config. Is it that you just don't want to mount a volume for the config? Because that's I think the way that most people go about it now is they just have a config file and mount it as a volume. So it could be read, but that's actually a good question. I know that we support plenty of flags. I don't know if we support the full extent of everything. Oops. Here, I mean, if you don't see it here, it's probably not available here. We don't include every single option I believe, inside of via flags. But if it's something that's needed, that should be actually a pretty easy contribution to make because it is available via the config, and I believe there's a pretty easy way to map flags to config inside of the NATS server. So, okay, Pablo asks, if I embed the NATS server in my Go app, can I join as a Leaf node and mirror some streams? Yeah, absolutely. For those of you who don't know, if you're writing Go, the NAT server is available to you to embed, which I think makes kind of this like peer-to-peer use case really kind of fun and interesting because you can do that. There's really no difference between you writing a Go program that embeds a NAT server and the NAT server. You just get to have your code wrap it essentially and do whatever it wants. So you can do all kinds of really fun, interesting things with that. And yeah, like I said, the NAT server should be as easy as, I could demonstrate it right now. Yeah, let's go do that. Let's go and embed a NAT server inside of a new project. I'm gonna just go make directory, NATS server embed. Whoops. If I could type, oh my goodness. I have too many things that are named the same. So let's go ahead and I'm just gonna go mod init code gangsta NATS server embed, and let's go get.com/natsio/NATS server. And we're just going to go get the package. Let's actually go here. And one of the things that you can see, and this is actually really interesting, is like a lot of the tests are driven this way. So all the tests you could see inside of NAT server actually do this. And so even if I go to like auth test, a lot of these tests will begin by just like running a server. So run auth server with token. Let's go see what this thing does. It's going to return a server to us. Can you take me there? There we go. And then it has this run server function, which exists right here. And all this is going to be doing is get a NAT server and run start with an option struct. And so, yeah, if you don't want to do the flags or anything like that, you want to configure this via struct, you absolutely can, and you can configure it however you need to be, so you can kind of like white label NATS, if you will. But you just import the server, you run it. Let's go ahead and do the same thing ourselves. We'll just say server or s equals, I think it's going to just NATS. Import NATS, or it'd be NATS server. It will be in the server package. Let's go server, NATS.io, NATS server, boom, dot run. Man, I cannot type today. This will return, could not import. Not v2, not enough arguments in run. It's going to take a server.server struct, which you can just initialize like this. So you can initialize with some opts and then go ahead and run it. So let's go ahead and do that. So I'm just going to say s equals server.new with server.options, and check this out. Lots of stuff to configure this with. We're obviously not going to use like all the stuff. We could just probably just use the default. But as you can see, all of the stuff that you have available in your config file, or if you just want to specify a config file, it's available to you, which is great. What happens when I just put in a blank one? Let's see. And then I could just say server dot, can I just say run on this? No, I have to say server dot run s. So if we do this, I believe this is going to block. Let's find out. think I also need to maybe specify an output for the for this. Make sure I'm not running any other NAT servers. You might need to specify an output for the logs, but it looks like this thing is blocking. Let's say NATS sub foobar context default. Yeah, so it's working. I am subscribing on foobar context default. So yeah, you might need to redirect the output of this so that you can, output the logs or specify a log or something like that. But yeah, I just embedded a NAT server that is just running all the default stuff in Go, and it took 2 lines of code. So that's pretty cool. All right. So that's how you embed a NAT server, in case anybody was interested in knowing. And that's how easy it is to do. I know a bunch of other questions kind of popped in while that was going. Yeah, so basically you can use NAT server as a framework like Cloudflare open source with there's a reverse proxy to build. I mean, yeah, if you want to build your own thing that utilizes NAT server under the hood, you absolutely can do that. There's lots of cool implementations. Maybe you're wanting to build some distributed file store, and so you want to use object store, and you just want to use NAT server under the hood, but you don't want to be able to tell your users to go install NAT server and run it in order to run your application. You just want them to run a single binary. That's kind of like a really good fit or use case for it. Okay, Zatho asks, I'm not found info on this, but do Jetstream servers wait until all replicas have received the message until they return, or they return after the majority has the message? I believe it is. I believe it's all of them. But I mean, sorry, this is how Raft works. So they need a quorum. So I believe in order for them to respond, Ari, you could probably jump in and add some more flavor here, but it does consistently replicate before the response hits, I believe. I could be totally wrong there. But John asks, is there any good way to store KVs regionally but allow them to be accessed globally? A bucket of users with personally identifiable information. Absolutely. So and that's the whole point of NATS KVs in general. And this is why NATS KVs are so cool, is because it just works like that out of the box. So I have my NATS context pointing to Synadia Cloud right now, and I'm gonna pull up Synadia Cloud for y'all, and I'm going to go into streams, and I have a bucket called my KV bucket. This is what I was using for the example in the video. Sorry, this is in the way. Let me pull this down. I have a bucket called my KV bucket right over here, and it just has one message in it. But if I go over to my KV bucket into the settings, you could see that this exists in Europe. But I can access this here, even though the cluster my client is connecting to when I run the CLI is going to be one on the west coast of the US. And so this is kind of the beauty behind all the location transparency stuff. The other neat thing about all of this, and this is what I showcased in the video, is that NATS is smart enough to where if I create a mirror in a cluster that is closer to me geographically, then those GET requests are going to be served up by that mirror. And so I automatically get lower latencies. I didn't have to change my configuration. I didn't have to change the configuration of my applications. They just automatically get all served up, which is awesome. And so, yeah, you can have a key value store that lives anywhere you want, but can be accessed no matter who you're connecting to. And this is something that I think is it's a really interesting thing to think through I think NATS has been designed very much to consider the location transparency even at a global scale. And which is not a lot of other technologies don't do this particularly well. I was even talking with somebody who was, saying, well, you say what KV watching is, how we do KV watching in NATS is fairly unique. But Redis has watches. Redis has notifications for that stuff. It's yes, but also the caveat is that doesn't work. It only works in the instance that thing was executed in. It doesn't work in a clustered mode. And so I think NATS considers like this whole geographic distribution for many of its things and making sure that it works. And I think that's where you can get a lot of the value there. So I think that's a great question, kind of asking, hey, if I put a KV store over in Europe, can I mirror it into another region very easily? And the answer is like, yes. I just create a mirror and it magically starts serving up requests where it needs to, which I think is really, really awesome. Okay. Yeah, John, to follow up there, you said, I assumed you could store them in separate buckets and mux them, but it looks like it would copy the entries. Yes. So the way you can think about a source and a mirror is that a mirror is a digital twin, meaning it's going to be like a true replication of those messages, whereas a source is more of a copy. And the reason being is when you're sourcing, you are sourcing into a completely different stream with a completely different set of sequence IDs, whereas a mirror is actually going to mirror and replicate them. So that's where you kind of have to draw the difference of like the idea of muxing and demuxing. You are treating those as separate streams or separate key value stores in that regard. Whereas if you want a digital twin of something, you're saying, I want this exact KV bucket with all the same sequence numbers, all of the same metadata, but I just want it in this other region. That is where you're going to want to use a mirror. So yeah, that's a good point. Question. Streams are limited to R5, however, it's fine to have more Jetstream enabled nodes in a single cluster to support more clients. Yeah. I didn't answer this whole thing. To support more client connections and distribute them better on nodes. Yeah. So this question came up on the Slack earlier as well. And I think it would be better just to draw this because it makes a lot more sense when you draw it. I think Ari even responded to this and his answer was like, yes, it's subtle, which is a great way to describe it because there's some subtlety at play here that's worth understanding. And it has to do with how how peers work in general or how membership works in general, because we have this idea of a cluster of things, right? And these are a cluster of NAT servers. And these NAT servers themselves are peers of one another. But when you start talking about Jetstream and Jetstream assets, the thing that you have to realize is we have a raft group for each asset as well. Like every consumer, not every consumer, but most consumers, every kind of stream. So imagine that we have like a stream over here. I'm going to make this stream all purple. Here we go. Imagine we have a stream over here, and this is going to be our R1. And then we have 2 and 3 over here. So there's an R3 stream, right? And this is going to be its own group that's managing this. And so in this example, we do have this kind of one-to-one of a server to a actual peer of this particular stream. But imagine if this existed inside of a meshed, and I'm going to mess this up because this is a full mesh, but just bear with me. A 5-node cluster. Okay. I'm just going to draw better lines. We'll draw a line here. And we'll draw a line here and everywhere. Okay. So we're getting closer here. I probably missed something. There we go. So now we have a 5-node cluster, right? But you can still have an R3 or a 3 replica of this stream over here. So you have this group and you're still having it just interact with the nodes that are relevant. And so, yeah, you can have a larger Jetstream cluster that is still kind of working out different sets of replicas here. So really only these 3 nodes are the ones that are involved with this particular stream. But I could also have another stream, right? Let's make this, maybe this is a key value store of some sort, and it's red. and it is using, these three as its group. So hopefully that makes sense. Why this works the way that it does, which is like you can have an outsized number of actual actual nodes in the cluster that are then like participating in different sizes of groups. The other cool part about this is you can have a lot more control of this. I know this looks like a mess. I'm like looking at it on my screen. You can have a lot more control over this when you're using things like tags, server tags. So you can like if you do, one of the problems is you might find imbalance here, especially if you're like adding peers to a previously running cluster. That can become, a problem pretty quickly. But you can use server tags to kind of have more control over like where these things get placed. So you can have like explicit control over maybe you want to have explicit groups where node A, B, and C are like always serving up, they're always trying to participate in similar groups or things like that. You can tag them accordingly. And so you can do some really interesting things there, but that's worth calling out is that you can have a large Jetstream cluster that is still kind of serving up these R3 streams, and they're doing so in an efficient way where obviously not every node is participating in that particular group. I hope that makes sense. Cool. Okay. Jesse says, that's really cool. Adding a bunch of nodes to a cluster and partitioning them for specific tasks. Yeah, you could totally do that. And the server tags don't necessarily just correspond to servers. Like you could do that for cluster identification as well, and use them for some like lightweight affinity of sorts. So yeah, there's some good stuff. Let's see. I know a lot of stuff came in. Yeah, replay for Office Hours 1 is here. We had a lot of video quality issues, so I actually like it's available via that link. I'm not sure if I wanted to keep it published, but yeah, we also had technical issues in this one, but I think this one does have some good content. And I will have to get Jean Noel back on for maybe the next Office Hours to kind of do a redo, because I agree it has some good content there. Okay, let's see. Yeah, Ari responded to the question around Jetstream, where all peers need to respond, and that way we know everything's consistent by the time you get a response that you get a pub ACK essentially, that it's consistent across all of its peers, which is great. Let's see if anything else came up. John also asks, any plans to consider batch delete? List or wildcard? Other systems tend to require deleting one by one. Again, I know Ari's in the chat, so he could expound on this. I know in the future, I don't believe it's scoped for 2.11, but more beyond 2.11, we want to try to have some. I know we want to have atomic writes, which technically, like a delete inside of a NATS KV, for instance, would technically be a write. I don't know how that would apply to purges or whatever, but I know we want to be able to have some form of like atomic commits or writes where you can kind of batch them up and do stuff like that. But that would be awesome. And yes, we do support purging kind of wildcards as well. But if you want to be able to do atomic writes, that's something we have scoped, but I don't think it's for 2.11. I think it's for a future one. Okay, how is the Synadia cloud infrastructure managed? That's a great question, Wayne, and I know somebody else also wanted me to kind of go over that. I don't have all of the details, and I would be doing it a disservice to say like how we are doing it. So I would love to try to bring somebody on from our ops team in a future episode once I get all of this guest shenanigans sorted, and maybe we kick off the next episode with the with talking about that subject, because it takes quite a lot, and all I really know about it is like there's surprisingly a lot of crazy differences in how not only certain regions work from a networking perspective, but just like all the differences between the three major clouds that offer their own challenge. But I know NATS kind of abstracts away a lot of that, which is great. So you can use something like Synadia Cloud to access all of those, or deploy in any of those, and have your communication taken care of without having to juggle all of like the weird discrepancies between how all the different networks work there. So, okay, yeah, I know. I know Yortis is also kind of hacking around in that topic related to like all the cloud infrastructure and stuff like that. But yeah, I'd love to get a more comprehensive answer to that question with somebody who's working on that stuff day in and day out. So, Phil, if you're listening to this, maybe I'll have to bring you on board, or one of your teammates on board. Um, okay, I'm gonna jump into the other chats. By the way, if you are listening to this on another platform other than YouTube, I'm kind of sourcing a lot of the questions from YouTube, but I'm periodically checking the other ones to see. It looks like most of our stuff is coming from YouTube, though, which is great. But if I missed you, then I am sorry. Okay. Let's see if there's any other questions that have come up. Can JetStream use consumer heartbeats to send in-progress state from messages? My NATS-based distributed schedule dedupe data from multiple instances, but every message requires a send in progress. So, I mean, I don't believe out of the box that you could just have the consumer heartbeats send in progress state. You would still have to do that yourself. The whole in progress is so like domain specific to you. We just kind of give you the primitives to set, what's the redelivery window. And when you say in progress, we're just going to assume it has something to do with like how you're processing that message, or what it looks like for you to kind of put a continued hold on that redelivery. Okay, what are the space and time performance properties of the magical yet a bit obscure subject-based indexing in JetStream? Are there compound indexes within the subject token space? I'm probably not as equipped to answer this, but I can give you a high-level overview of some of the data structures involved here, and maybe folks in the chat can expound here. But just to kind of give like a high-level overview of just subscriptions in general. Because I guess we could take subject-based indexing and kind of like analyze it from a purely like, I don't know, string tokenization perspective, but that's not as interesting. But basically, like one way to think about it is that imagine that we have, I'm going to copy this again. Imagine that we have a NATS cluster. And at its core, we have this thing called the interest graph, and the interest graph is basically a graph that it has that holds all of the subscriptions essentially. So you have all these kind of clients, right, that are connecting into NATS in various ways. We have one over here on this server. We have one over here in this server. We have another one in this server. And then we have one over here in this server. So these clients are all connecting in. And the magic of NATS is that these guys don't really have to care about who they're talking to. Like this guy doesn't need to know the IP address of this guy. But instead, we can just use NATS to kind of figure out all of the delivery semantics for us, right? And so, oops, I don't know why that's gone the way it is. Okay. And so yeah, this guy doesn't need to know this guy's IP address or this guy's IP address, and they could even be talking across the globe from one another, and that's great. So some of the way that this works is we store this kind of interest graph, which is just a data structure of all of the subscriptions that are held by clients and who those clients are so that they can be delivered. And this interest graph is, when a client makes a subscription, it's updated and propagated to each of the peers inside of the cluster, so that all of the cluster's peers can know where things route to, and we can do efficient routing around that. I believe it's a little bit different how stuff is kind of propagated over gateways, and it's certainly different how it's propagated over leaf nodes. But between a cluster and a supercluster, this whole interest graph is propagated across all nodes. There's no like idea of sharding or anything like that. If you want more kind of a sharded like interest graph, like that's where kind of leaf nodes come into play a little bit because they do have explicit like subject propagation there. But for the most part, all of this stuff is essentially replicated in memory between all of these nodes. And so I know there has been some work, and I'm not sure if it's in the interest graph or if it's in somewhere else, but we recently switched to like a S tree implementation for some of this stuff regarding subjects. That might have just been in Jetstream, but like there's optimizations that we continue to make in this space, and so I don't think we necessarily have like hard time and space constraints about how this stuff works, but there have been improvements from previous versions there. So anyway, that's kind of a high level overview of how stuff in NATS is kind of like the subject graph is propagated amongst all this stuff. And I know Ari's kind of participating in the chat, talking about those as well, like specifically for Jetstream and indexing, that it's something that we try to just keep under the covers because we just like don't necessarily feel like people need to be thinking about all of those details there. That we're just going to continue to optimize it and use the data structures that we need to continue to optimize it for those use cases. One of the challenges with trying to one of the challenges is really trying to handle a lot of different access patterns, right? And keeping it efficient. And it's something that I think NATS actually does do wonderfully, but it's a hard challenge at the end of the day. And one reason you could think about this is like something like even though under the hood they're very similar, something like a stream of data is still very different access pattern wise than a KV store, right? So a stream of data, you typically have a sequence of data, and like if somebody's processing it via stream processor, usually they're just working their way through that stream one by one. They're accessing it fairly linearly, and so it's easy for them to whip through and do that. And this is why things like Kafka is like it's an append-only log, so it's going to be really fast for throughput because it's literally just acting as an append-only log. Whereas like a KV is going to have a lot more random access and certainly a lot more deletes. And so when you're thinking about like more of a KV style where you might have TTLs on all of these and these keys are falling off randomly, you're going to run into a problem that we've run into, which is like, okay, now we have all of these random like deletions and we have to kind of handle these internal deletes efficiently so that we can only keep the keys that we need. So it's no longer kind of this sequential data problem that we're dealing with, but we're now dealing with a lot more random access patterns in terms of when deletes are triggered and when things essentially fall off of the data set. And so that's why like we're going to continue to optimize and start using even more exotic algorithms and data structures for how all of this stuff works under the hood, so we can continue to optimize for the use case. So, yeah, I don't know if that's the answer that you were looking for. I wasn't going to give a computer sciencey, here's what we do, but here are some of the constraints that we're working under, and here's some of the higher level, like how we propagate the subject graph or the interest graph. Another question is, any plans on integration with Grafana? NATS looks really nice to be used as glue between Grafana dashboards and microservices. Micros can make Grafana into a control panel, streams, fill charts in real time. Yeah, I mean, so we have, it's a good question. I mean, so far the way we've kind of taken it, and a lot of this could be due to the fact that NATS is a CNCF based project. And so there's a lot of opinions or even community, like a lot of things that the community has settled on to use. And one of those is kind of Prometheus and Grafana just being like the golden duo. It would be interesting to kind of like have NATS drive more Grafana itself. But, a lot of people have been totally fine just integrating like and monitoring NATS via the NATS Prometheus exporter. Either Surveyor or the NATS Prometheus exporter. But I think what you're getting to, Alexander, is like the idea of like, why can't we just use NATS as a backend to Grafana? And to that I say, that sounds really interesting. That would be super fun. And it sounds like a super fun project to do. Yep. To Ari's point, talking about just like performance and access patterns, This was in response to him saying we are aiming to support tens of millions of more keys per single KV. Yeah, and we always have we have users doing that today. We're improving stuff. People always want to push it further. We honestly get stuff where people, large organizations are like, we want this many keys in our key value store, and we want to be able to replicate it and have it serve under 10 milliseconds anywhere in the world or whatever. And it could be a lot of keys, right? So I think we're just going to continue to go in this way, where I feel like a global key value store is really what people want, right? Where they can just put like a billion keys in there and just have it consistent and easy to access and replicate it everywhere, so it can be quick. Yeah, that's the dream. And so I think we definitely want to support lots and lots and lots more keys, and the community continues to push it further. All right. I have done a POC with 100 million keys in KV and no problem. Yeah, get any key within that 100 million was very fast. Absolutely. I actually think like putting a bunch of data in the KV and like getting at it, that's actually like that actually does fine, especially in a POC. I think it's when you get into production use cases, it could get really difficult depending on how hot that particular key is, or depending on how fast you're expiring things. Internal deletes can be a killer in a lot of ways. And so it all depends on the access patterns of that too. Because it's easy to simplify KV of like, I'm just putting data in and taking data out. But in this particular use case, there is a lot going on under the hood to try to keep track of all of that. Pablo, thanks for joining us. I'm sorry you have to go, but we will have a replay of this. And thanks for asking all those great questions. Yordis, when talking of Next, Next is using NATS for all of its logs, by the way. I guess somebody might have asked a logging question. But we have plenty of people. There's been infrastructure companies, popular ones that I may not name, that have used either in the past or in the present, like NATS as part of its logging infrastructure. It can be really good for that. A little kind of hack is every time I kind of am like writing a little microservice or something, if I'm, especially for demos and stuff like that, I'll just redirect a lot of my log output to core NATS. and it's like, if somebody's interested in grabbing it or even throwing it into a stream, they can, but it's just there, in case you want it. It's fairly inexpensive to be able to kind of write those log files to NATS itself. More expensive if you want to do it to Jetstream out of the gate, but it's kind of fun just having a subject available to listen to be like, oh, here are the logs for this particular microservice. It's pretty fun. And then you could just get at logs via the NATS CLI super easily. All right. Thanks everybody for asking all of these questions. We've actually filled up our time quite a bit. I don't even think we covered some of the other stuff that kind of was in this 2.9 release. So I guess let's try to go back to that. And I can also jump in and ask more questions. There's so much to go over. I want to try to, I want to cover our Synadia cloud infrastructure in maybe our next office hours. I also want to do a redux and have Ari show us this tracing stuff, because it's really, really cool. It's on me to figure out how we do all of the guests from here on out, because definitely screwed that one up. So let's go back to our NATS 2.10 release, or 2.11 preview. Where did that go? Let's pull it back up. Here we go. Okay, so the other really cool thing that has been brought into Jetstream is direct gets from streams. Not only streams, but KVs. And I believe that Ari, he was showing this in our Slack as well the other day, where you could just do some really, really neat things, like have, a representation of a map inside of a KV, where I can say I could just use subject-based addressing to be like, here's this user with an ID and an email and a description, a title, a bio, and you can just pull those things out and serialize that or deserialize it into a struct in your language of choice, and you just do that with one API call, which is just so awesome. I love that. And so we have batch direct gets, and that's not just for KVs, but it would be for streams as well. So even in one of my previous videos, I kind of showed a consumer to kind of like whip through and grab, the last 5 relevant subjects for a particular key space. You can now do something like this without having to essentially create a consumer. Which is actually very lightweight, and so that's so cool. This is going to be a huge feature, and I'm sure a bunch of patterns will kind of emerge out of it. And I'm really, really excited for it. We also had support for pausing and resuming consumers, which I bet I think Yortis, you are also kind of helping implement some of the client side stuff. Thanks for doing that. It's always fun having more people in the community participate and contributing there. And batch direct multi-get requests from streams. And again, we have an ADR that outlines all of this. For those of you who don't know, we document all of our design decisions for NATS, both for the clients and for the server. And so if you want to kind of get a preview into some of the things that we're thinking through, there's a lot that you can do there. There's a lot that you can look up and see how we're thinking through solving some of these problems. Okay, we had a couple questions that popped up. Pablo asks, also for Jetstream, what are the ways the application will need to be able to ask for new messages since it's a specific sequence? Yeah, maybe I'm missing a previous question, Pablo, but I'm not sure I'm fully understanding that question. Ask for new messages since it's a specific sequence. I'll have to come back. If you could kind of try to clarify what you're asking there, I can try to answer it a little bit better. Okay, let's see. Okay. Maybe this is what your previous question is. Does an ephemeral consumer exist on a single node? Does it make sense to recreate an ephemeral consumer on each HTTP request for long polling? Again, some of these new APIs that are coming around the batch gets might kind of remove some of the needs for ephemeral consumers. For HTTP and long polling, like maybe that could make some sense. Like ephemeral consumers are still, they're fairly lightweight to fire up, but you're not going to want to fire up, hundreds of thousands of them or tens of thousands of them at the same time. They're still consumers. They're still going to like use up some resources, and they still kind of stick around, right? But it's all going to just depend on your use case and everything. I always recommend, and this is probably me being like the it depends guy, but NATS is easy and fun enough to be able to like build a POC around that. So I would say like go take a couple hours and try it out for yourself, see where it falls over, because there are just so many variables involved. It would be hard to say like, will this work? But good question. Didrik said, sounds like per key TTLs could be pretty destructive for performance, at least putting on my Dusty CS hat. Sounds like a hard problem. It's a hard problem. Yeah. And so I think, again, this is going to I think it will likely, have some performance impacts. I know the team's thinking hard about how to introduce that, but it's likely going to introduce just yet another variable into ways that performance can be impacted with KVs, because we aim for kind of flexibility and adaptability, which I think gives teams a lot. And we try to remain as performant as possible in those use cases, and I think it's going to get better over time. But we will see where the per key TTLs could leave us, because essentially, we have like a timer per key could be very intense on performance. Let's see what other stuff has come up and if I missed anything. LW asking about leaf nodes, and you might have gotten this answered in the comments, but regarding infinitely extendable cluster. If this is viable, would I just have to append to the config leaf nodes remotes URLs and all of the NAT servers in my cluster, not trying to spam? Yeah, and so great question. Yeah, and so you would want to append whatever servers you want to those remotes. Something to keep in mind is that leaf nodes are like daisy chainable, and so anything that you kind of let go over the leaf node, again, those subscriptions get propagated as long as you kind of let it go over the wire, depending on how you lock down permissions and stuff like that. You can effectively daisy chain leaf nodes, and so you could even think about this as like a distributed, a blockchain might be a good way to think about this, where you have kind of like your seed servers, but those lead to other peers, and you can, connect to any one of those peers, and traffic can flow between them. That's one way to go about it. You can, like I said, you could daisy chain, so you could have one peer serve up traffic for two adjacent peers that might have different interests, and so that node is just essentially used as a connection box or like a traffic box. Or you can do like hard peering, where you're saying, I only talk to the people that I connect to. You have options there. Leaf nodes can do both of those things. So, let's see. I know we are almost at time. We have about 10 minutes according to our schedule. But we did have more questions come up. And these are all good questions. These are hardballs, which is what I wanted. I wanted a hardball question. I wanted to be able to jump up and draw. So thanks for everybody who's like leaning into this, because I know it's a new format for us. Gosh, we had so many questions come up. Okay. Are there any news/plans on the built-in MQTT support? Thinking about Leaf Node setup to bridge older MQTT clients already at the edge. The good news is if you have an older MQTT client that's using, that's not using MQTT 5 or whatever it is, then you should be good. And yeah, we are making improvements, because we do have people who are using this MQTT thing in production. I don't know what plans we have necessarily to continue to support MQTT5, which it's quite different in terms of protocol support. But I know that we have plenty of people that are using MQTT that we would like to continue to support. So it's certainly not out of the question. And we also, like, even in this release, we already have some like MQTT improvements that are or changes that are coming. So yeah, something to consider there. All right. Let's see. Shmuel said, and sorry if I'm pronouncing that incorrectly, Shmuel says, a nice reference architecture document for deploying a small 3-node cluster to, say, AWS would be helpful. As a developer, it's great, but IT folks usually want a template to start from. I hear you loud and clear, and that's actually a really, really good piece of feedback, which is I think we on the team interact with a lot of developers day in and day out, where they're like, yeah, I'll stand up a server and POC this and everything like that. And I think it's important for folks who are in other disciplines or other departments or anything like that, that we have better supporting documentation, that we have some maybe golden path architectures there. And so it's something that we've been thinking about a bit. And I think from a documentation perspective, it would be great for us to have some reference architecture, so folks are confident that what they're deploying is something that's working. Okay. Let's see if anything else. By the way, is it possible to replicate buckets in Synadia Cloud? It sure is. It sure is, Yordis. Let me show you that right now. It's very easy. You just go here, you go create stream, and you're going to create a mirror. All right. That mirror can target a stream, but it could also target a KV. So I can say I want to replicate this leadership KV, and I'm just going to call this, leadership KV mirror. And then I can choose where to put it. I can say I want this over in US East 1 on GCP. And apparently there's no suitable peers in that place. So let's try Azure US West. There we go. And now I have a mirror. So I've now replicated that stream, and all gets are going to be served from that if it's geographically closer than the leader. So S3 bucket naming, sad face. Oh, okay. You meant object store. Object stores. Yeah, I don't know if we have mirroring support for object stores yet. I haven't even tried it, to be honest. But if it's not available, we can look into what we might need to do that. Yeah. Any thoughts on migrating to Discord, more hipster, less corpo? I mean, yeah, Discord's cool. It has a lot of really neat stuff. I mean, we've been building up our Slack community, and I know Slack is what we use internally, so it helps get more of our engineers on board. But yeah, we'll figure out more ways to engage with the community in more hipster ways. I know that the YouTube, the live streams, these are all kind of us getting with the times. Which I think is good. It's a good way to kind of reach out to the community. So no plans to move to Discord, but we'll continue to do more things to adopt, modern community outreach. Great. Let's see. I think that's most of the questions. I'm going to pop in and see if there's stuff from any other channels. But I think we're looking good here. Again, sorry folks that I wasn't able to bring anybody on. I'm pretty bummed about that, but I think this is going to be a good place to kind of wrap up. Thanks Ari for jumping in and participating in the chat. It was super useful. Oh, actually, let's see. There's one more that came up from Pablo that I think would be cool. Can I use a leaf node as a transparent disk buffer for an app installed as a sidecar? By transparent, I mean that I won't need to change the config of the main NATS cluster. I'm not sure what you mean about disk buffer, but like, let's say you want to mirror something. So if you want a leaf node connection, you don't necessarily have to have it on. You don't have to have the configuration on the main NAS cluster. You just have to have the configuration on the leaf node side to be able to make that connection. And so, yeah, you could essentially transparently extend any cluster, including the cluster NGS, which is behind Synadia Cloud. So you can like transparently extend that, and we actually encourage people to do so. Because that's that's a way that you can also save on cost. But also, like, if you have a single NATS cluster and you want to give it like this global availability, you can do that with Synadia Cloud. So imagine that you have like your own streams inside of your own cluster, and then you just simply want to mirror them all over the world. So you get those nice fast reads and stuff like that, but you still have your main written stream inside of your leaf node cluster. You can absolutely do that. So there's a lot of really cool patterns that can emerge when you have leaf nodes and you combine that with replication and all sorts of fun stuff like that. So I think that's where I'm going to leave it. One more question. Any plans on integrating S3 as cold storage for streams? We hear you about that. I know Byron, our VP of product, he's definitely like our local event sourcing master. And I think that's one thing that especially the event sourcing community likes, is kind of just the idea of tiered storage. The only thing that we have that's even like remotely similar to tiered storage would be that you can have a stream that's, replicated or mirrored that has a longer retention rules, and that might be on like spinning Rust or something, while your main stream would be on SSDs. That's as far as we go right now, but it would be cool to have like better tiered storage. I know like people laud Pulsar's tiered storage solutions for that. We just don't have anything like that right now. So, but we've heard it before, and I think it's something we want to tackle at some point. Okay, I think that's a good place to stop. Thanks everybody for participating. Like, this was actually a pretty fun-filled and nicely chaotic stream. And hopefully in another 2 weeks, we can bring some more Synadia folks on that isn't me, because I just know a little bit about like most things. And I want to bring in people that know a lot about the things that you guys are asking questions for. So thanks so much for jumping on board, and I'll see you on the next stream. If you haven't watched the new KV video, go ahead and give it a watch, and look forward to a microservices video coming out soon. All right. Thanks everybody. It was good to see you, and I will see you soon. All right. Bye.